Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 12 titled Blind SQL Injection with Conditional Errors. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, go down, select the learning path, go down, select SQL injection, go down one more time, select blind SQL injection, and then select the second lab in this section titled Blind SQL Injection with Conditional Errors. All right, let's get started. This lab contains a blind SQL injection vulnerability. The application uses a tracking cookie for analytics and performs a SQL query containing the value of the submitted cookie. Okay, so we have the vulnerable parameter is the tracking cookie. The results of the SQL query are not returned, and the application does not respond any differently based on whether the query returns any rows. Okay, so because the results of the SQL query are not returned, that means we can't use union-based SQL injection. And because the application does not respond any differently based on whether the query returns any rows, we can't use blind-based SQL injection based on conditional responses. And that's because we can't differentiate between a true response versus a false response. So we're going to have to use a different method. So if the SQL query causes an error, then the application returns a custom error message. Okay, so we're going to have to use blind-based SQL injection based on conditional errors, because we do get an error when the SQL query causes an error, and we don't get an error when the SQL query is well formatted. Okay, so the database contains a different table called users with columns called username and password. You need to exploit the blind SQL injection vulnerability to find out the password of the administrator user. To solve the lab, log in as the administrator user. So we have a few angles over here. The first is to output the administrator password by exploiting the SQL injection, and the second is to log in as the administrator user. Okay, let's access the lab, right click and open it. This might take some time, so we'll create the analysis section. And in the meantime, we're gonna open up Burp because we'll need it. And I'm gonna use the professional version of Burp just because it's much faster when you're using Burp in Tutor, but you can do everything that I'm doing with the community edition. All right, click next, start Burp. All right, it looks like it loaded up, so let's put Burp on the other side. Go to the Proxy tab. Intercept is set to on. Next, we need to configure our browser to send requests to Burp, so we'll do that using the Foxy Proxy extension and selecting the option Burp. Now, when we click on a request, it should be sent to Burp. So let's click on Home, and here we go. We see it in Burp. So click Forward. Intercept off, go back to HTTP history, and let's send this to repeater. Okay, so we'll be working from Burp from now on because we need to send a ton of requests and it becomes really annoying to do that from the browser. Okay, so based on the exercise, the vulnerable parameter is the tracking ID cookie. So what I'm going to do is I'm going to put a single quote and see if I can break the query. So this single quote should interfere with the SQL query and cause an error at the backend, which we should see in the application. So let's hit send, and here we go. So we get a 500 internal server error. Now I'm going to try and close that single quote and see if I still get that 500 internal server error. Hit send. And I don't. So I get the same page that you would get over here if you had just clicked on, for example, home or my account or whatnot. Okay, so that's a good sign. We still haven't proved that it's vulnerable to SQL injection, although we have an inclination that it is, because when we try to break the query with only a single quote, we get an error, but when we close that single quote, we no longer get an error. So first step is to prove that parameter is vulnerable. Okay, and to do that, we're going to be using SQL code and see if it interprets it, if the application interprets it as SQL code in the backend. So far we've added 2 single quotes and we don't get an error. So next, let's add the concatenation character and use another query. So select empty string and then concatenate that. All right, let's copy this and see if we get an error or if we get a 200 response. Now, this is a well-formatted SQL query, and so we shouldn't get an error. So let's test it out. And then do Control-U to URL encode it. Hit send. And we get an internal server error, which is weird because, again, this is a well-formatted SQL query. And so what this indicates is maybe we're not dealing with a MySQL database. Maybe we're dealing with an Oracle database, because an Oracle database requires a from clause in order for the query to be valid. So what I'm going to do is test that out and say from the dual table, which is just a dummy table that we can use. And that's something we learned about in previous labs. So if this doesn't give me an error, that means I'm dealing with an Oracle database and that this is definitely being interpreted as SQL code. And so it's vulnerable to a SQL injection. So let's paste this. Control-U to URL encode it. Hit send. And we don't get an error. So this indicates to me that we're dealing with an Oracle database, which is good to know because this way we could form our queries so that they have Oracle syntax. And it also tells me that this is very likely vulnerable to a SQL injection. And to confirm that, what I'm going to do is I'm going to try and get it to output something from a table that doesn't exist. So I should get an error on that because that's a table that doesn't exist in the database. So Control-V to paste it, and then Control-U to URL encode it. Hit send. And here we go. We get an error. So this confirms to me that we're definitely dealing with a SQL injection. All right. So the next thing we want to do is confirm that the users table exists in the database. And we'll do it exactly in this way. So let's copy this query over here and say select nothing from the users table. If the users table doesn't exist, it should throw an error. If the users table does exist, it should give us a 200 response. So let's copy that. Control-V to paste it, and then Control-U to URL encode it. Hit send, and we still get an internal server error, which means that we did something wrong. Okay, so what likely went wrong is that this will output an empty entry for each entry in the users table. So if the users table has 5 entries, so 5 usernames, that means this will be outputted in 5 different rows, which might break our query. And so what I'm going to do is I'm going to say where row num is equal to 1, and this ensures it only outputs 1 entry. Okay, let's copy that, paste it in here, Control-U to URL encode it, and then hit send, and we get a 200 response, which indicates that the users table exists. Okay, so the next thing to do is confirm that that the administrator user exists in the user's database. Because that's a user that we want to output the password, so we have to make sure that it exists before we try and output the password of that user. Now, you might want to try this. So select an empty entry from the user's table where username is equal to administrator. However, this wouldn't work because if the user administrator exists in the database, we get a 200 response. If the user administrator does not exist in the database, it just doesn't run the select portion of the statement. So it doesn't give you an error either way. And so you can't tell whether that user actually exists in the database or not. We need to be a little bit smarter, and we'll do that in a second, but let's test it out over here. So if you have a valid user, it shouldn't generate an error. And then even if you don't have a valid user, it also shouldn't generate a syntax error, and that's why you should also get a 200 response, which makes it difficult to determine whether this is actually a valid user or not. So like I said, we need to be a little bit smarter, and the way to do that is to use the case expression in Oracle. So it's similar to the if-else then statement. And the way to do that, we're going to copy this over here, is we're going to say if the case when 1 is equal to 1, then perform a certain function. So let's leave that empty for now. Otherwise, perform something else. Again, we're going to leave that empty for now. And then we're going to end it and then say it's from a certain table. Again, we need the from clause because Oracle databases always require it or you get an error. Okay, so we're going to say select the case when 1 is equal to 1. Then use the toChar function, which is just simply an Oracle function that converts a number or a date to string. And over here, what we're going to do is divide by 0. So this is invalid, so this should generate an error. Otherwise, it's just an empty string. So what we're doing over here is we're saying when 1 is equal to 1, which will always be true, then perform this function with this invalid parameter. And so you should get an error. Now, if we say 1 is equal to 0, then it shouldn't get to this function at all. It should get to the else statement, and then it should output an empty string, which means that we get a 200 response because we don't get an error. So let's try that out first, and then we'll try the use case. And then in a bit, I'll explain how we can use that in order to determine if the administrator user exists in the user's table. So Command V to paste it, and then Control U to URL encode it, and hit send. And we get a 200 response. Good. That means it didn't reach this statement over here. Instead, it reached the else clause. Next, let's put 1 is equal to 1 and hit send. And we should get an error. Perfect. All right. So now we have a way of getting an error based on whether this statement over here is true or not. So we're going to use that to our advantage to determine if the username exists in the database. So in the from clause, instead of using dual, which is our dummy table, we're going to say from users table where username is equal to administrator. Okay, so in order to understand why this will help us determine whether the username exists or not, you need to understand the order of execution when it comes to SQL queries. So the from clause is evaluated first before the select clause is. So in this case, when we say from the users table where username is equal to administrator, so if the username administrator exists in the database, then perform the select section of the query. If the username administrator doesn't exist in the database, the select section of the query will not be performed. So we're going to use that to our advantage to determine if this is true or not, because if the user's table exists and it has a username that is called administrator, then it'll perform the select portion of the query. And then the select portion says select the case when 1 is equal to 1. Now 1 will always be equal to 1, and so it will perform the toChar function, which will try to divide by 0 and generate an error. Now if the user administrator doesn't exist in the database, it won't perform this portion of the SQL query, and so it will never perform the toChar function, and so it won't output an error. So we'll try both use cases to confirm that this is correct. So we'll first try with the correct use case where the administrator exists in the database. So Command V and then Control U to URL encode it and hit send. And we get an internal server error, and I'll put that on a new line, which means that the administrator user exists. And again, this is a bit difficult to understand, but the reason that works is because over here, the users table exists and the username administrator exists in the users table. And so it'll perform the select portion of the query, which says if 1 is equal to 1, then do this, otherwise do this. And in this case, 1 is equal to 1 will always be true. And so it'll perform this portion of the query, which should generate an error at the back end. And that's what we saw over here. Now, to confirm your understanding of this, let's try doing it with a username that does not exist. So let's say a random username. We should get a 200 response. Again, don't forget to do Control U to URL encode it, hit send, and we get a 200 response. So let's make note of that. And that means user does not exist in database. Okay, so why did that happen? Because when it said the from users where username is so-and-so, this username does not exist in the database, and so it didn't run this portion of the query. And so it never had to run the toChar function, so it never got an error, and that's why we get a 200 response. Okay, so we've confirmed that the administrator user exists in the database. The next thing is to output the password of the administrator user. But before we do that, we need to first find out what the length of the password is. So determine length of password. And to do that, we'll use exactly this. So from users where username is equal to administrator, and the length of the password is bigger than 1. Okay, so again, if the length of the password is bigger than 1 and the username administrator exists in the users table, then this will run as well and we should get an error. If the length of the password is not bigger than 1, then we shouldn't get an error because this doesn't run. Okay, so let's try that. So we're pretty confident that the length of the password has to be bigger than 1 because you don't want an empty password. So we should get an error. Control U to URL encode it, hit send, and we get an error, which is good. So now let's try a big number, for example, 50, and see if we still get an error. If we still get an error, that means the length of the password is bigger than 50. If we don't get an error, that means the length of the password has to be smaller than 50. Control U to URL encode it, hit send, and here we go. We get a 200 response at 50, which means length of password is less than 50. Okay, so we know that the length is bigger than 1 but less than 50. So we could try, is it bigger than 2? And if we get an error, that means it's bigger than 2. We could try then bigger than 3. If we get an error, that means it's bigger than 3, and so on, until we get a 200 response, just like we did for 50. However, that is a lot of requests, and so instead of doing it by hand, we're going to do it using Intruder. So I'm going to right-click and select Send to Intruder. And then from there, I'm going to clear all the positions. The only position I'm interested in enumerating is this one. So I'm going to click Add, and I'm going to put it back to 1. And then for payloads, I'm going to click numbers, and it's sequential. I want it to start from 1 to 50 because I know for sure that the password is not bigger than 50. And then the step count is 1, and what that means, it'll increase by 1 each time. So it'll start with 1, and then 2, and then 3, and so on, and that's why there's 50 requests in the request count. And then I'm going to click on Start Attack. Now, you should be able to do this with the Community Edition. It just will take a little bit longer than the Professional Edition. So notice over here, at 1, we get a 500 response code because it is bigger than 1. Same goes with 2 and so on. So we're looking for a 200 response code. And here we go. So we start getting a 200 response code starting with the payload 20. And so when we did, is the length of the password bigger than 20? It gave us a 200 response code, which means no, that the length of the password is not bigger than 20. And the reason is because it's exactly 20 characters. And we know that because at 19 characters, we said, is it bigger than 19? Then yes. So we know for sure that it's bigger than 19, but not bigger than 20. And that means it's exactly 20 characters. Okay. So now that we know the length of the password, the last step is to output the administrator password. And the way we're going to do that is similar to this over here. And what we're going to do is we're going to ask, is the first letter of the password equal to A? If it is, then output an error. If it's not, then output a 200 response. And then we'll do that for the second character, third character, and so on until we've enumerated all 20 characters. So let's build our query. So we no longer need the length because we know the length of the password, but instead we're going to replace that with the substring method, which we used in previous labs. So we're going to ask if the first letter of the password is equal to the letter A. Okay, so when this SQL query is run, the first thing that is going to run is the from clause, which will ask from the users table, is there a username that is administrator and the first character of the password equal to A? If it is, then it'll run this. And when you run this, it'll ask, is it the case that 1 is equal to 1? It is, and so it'll run the to-char statement where you divide by 0 and you get an error. Otherwise, it will output an empty string. And so if the first character of the password is not A, we should get a 200 response. If the first character is A, we should get a 500 response code. So let's copy that and test it out in repeater first. So discard this, go back to repeater. Do Control U to URL encode it, hit send, and we get a 200 response, which means A is not the first character of the password. Okay, so instead of doing this again by hand, we're going to do it using intruder. Go to positions, clear all the positions, and the one I'm interested in enumerating right now is this one. So click add. Instead of just trying A, I want to try all the alphanumeric characters. So I'm going to click on brute forcer, and this tries all the alphanumeric characters. Minimum length 1, maximum length is 1 because I want to try one character at a time instead of permutations of those characters. And we've got 36 requests. Hit start attack. And what I'm looking for is a 500 response code. Because if we get a 500 response code, that means this was true, which resulted in this being run. So let's look for that. So they're all 200 so far. And here we go. We get a 500 response code, which means that the first character is W. Now, the next thing we need to do is try for the second character, and then the third character, and then the fourth character, and so on. So instead of doing that again 20 times in burp intruder, I'm going to automate that portion as well, all in one attack. So in positions, let's clear one more time and add this as a position, and then add this as a position as well. So for the first one over here, it'll be numbers. So numbers, again from 1 to 20 because we know there's only 20 characters in the password, and we step one at a time. So what this will do is it'll try 1 and then 2 and then 3 and so on. And then for the second payload, which is this one over here, so you have to change it to cluster bomb first of all. Over here, the second payload would be the alphanumeric characters, so I'm going to use brute forcer, which tries all the alphanumeric characters, and the minimum length is 1 and maximum length is 1 because I want to try one character at a time. So you'll see over here between the first payload and the second payload, there's 720 requests, and so this would be very difficult to do by hand. In the professional version of Intruder, it's really fast. In the community edition, it might take hours to do. So if you don't have the professional version, stick around and we'll script this in Python where it'll take minutes instead of hours. Okay, so it's running. So if you go down, these are all 200 response codes. We've got a 500 over here, which means that the 19th character of a password is B. Okay, so it looks like it finished running. What we could do is just order by status over here, and what it's going to do is it's going to put all the 500s first. So you could see over here at 14, at the 14th position of the password, we've got a B. At the 19th position of the password, we've got a B as well. At the 4th position of the password, we've got a C, and so on. So what I'm going to do is, first of all, filter on only the 500 response code because that's the one that I'm interested in. You won't be able to do that in the community edition. I believe that's only available in the professional edition. So I'm going to click on apply, and now I can only see my 500 response codes, and then I'm going to order on payload. So over here, starting with 1, we've got a W, which we already found when we were doing it manually in Repeater. And then at position 10, so I'm just going to put a few spaces over here. At position 10, it was 6, and then position 11, it was S, and so on. So you've got S, Z, H, B, T, F, 0, C, B, and then F over here for position 20, and then go back to position 2, it's J, F, U, C, 4, 9, 7, W, and L. Okay, so this should be our password. Let's copy it and try to log in using it. So click on My Account. For the username, select Administrator. For the password, paste the password and click Login. And it says it's an invalid password, so we might have copied something wrong. So let's go back. So we've got W, and then for the second one over here, we've got J, and here we go. So I copied the F twice when it's only supposed to be for position 20. Okay, so this should work. Let's copy it one more time. Username is administrator, and the password is this one over here. Hit login, and here we go. It says, congratulations, you solved the lab. All right, so we successfully completed the exercise by using Burp Suite Professional. Now let's try and script it using Python. Okay, the first thing we do is import the sys library and the requests library. Next, we import URL lib3 and URL lib.parse because we're going to need that as well. And then we'll add this line over here in order to disable any request warnings from certificates. So URL lib3.disable warnings, and it's URL lib3.exceptions.insecure request warning. Okay. And then we're going to set our proxy setting so that any request we make through the script gets passed to our proxy, and this helps with debugging if the script doesn't work as intended. So HTTP 127.0.0.1 8080, and then we'll do that for HTTPS as well. 127.0.0.1, and again 8080. Okay, that looks good. Next, let's call our main function. So if name is equal to main, then call the main function. So this will run when you run the program, which will run the main function over here. And the way I want my script to run is it would be script.py, so the name of the script, and then you give it a URL, and then it exploits the SQL injection in order to output the password of the administrator. So it only takes in one parameter, which is the URL. So we're going to say if the length of the arguments, so sys.argv, is not equal to 2, so that would be the name of the program and the URL string, then I want you to print the usage instructions, so name of the program, and then URL, because you're not running it correctly, so I'm giving you instructions on how to run it instead of giving you an error, which doesn't look too pretty. So this is the name of the program. All right. And then I want to give you example instructions on how to run it as well, just to make it a little bit clearer. So example would be the name of the program. And then for example, the URL could be www.example.com. Okay, and then exit the program because you ran it incorrectly. All right, so assuming you did run it correctly, I'm going to assign the parameter, so the URL parameter, to the variable URL over here. So we'll take that from the argument, so it would be argument 1, and then I'm going to print retrieving administrator password, and then I'm going to retrieve the administrator password using the function SQLi password URL. All right, so let's implement that function over here. So def SQLi password, and again it takes in the URL. We're going to create a variable called password extracted, which is empty for now, but it'll save the password, the characters of the password, as we extract them, because we're extracting them one by one, just like we did with the requests over here. Next, I'm going to say for I in the range 1 to 21. And the reason we use 21 is because it'll go to that range -1. And so it'll try 1, 2, 3 up till 20 instead of up till 21. Okay, and then I'm going to say for J in range 32 to 126. Okay, and I'm using ASCII characters over here. We've explained that in the previous lab. However, if you haven't watched that video, I'll explain it again. So let's Google ASCII table. Click on it. Okay, here we go. So instead of creating an array that has all the alphanumeric characters in it, so what I'm going to do is I'm going to use the decimal number that represents that character. So we start off with 32, which over here represents a space, and then we go all the way to 126, which is over here, represents this sign over here. So we try not only the alphanumeric characters, it's also case sensitive, and we also try all the special characters as well. Okay, so I'm going to close that right now. Next, we're going to set a variable called SQL payload, and that's the SQL payload that will exploit the SQL injection. So we'll get that from over here. So let's copy that. Paste it. Okay, so we've got two variables over here. This is the first one. So percent sign S, and this is the second one. Okay, and the first one will be replaced by I, and then the second one will be replaced by J. So what this is going to do is it'll start with the first character of the password. So the first position, which is the first character 1, and then it'll try all the characters in this range until it finds one, and then it'll move on to the second position of the password, so the second character, and so on. Okay, the next thing we need to do is URL encode our payload. So let's say encoded. And that's where we use this library over here, which is why we needed to import it. Okay, so it would be URL lib.parse.quote. And that would be the SQLi payload. Okay, next we need to set the cookies. So there were 2 cookies that we were using. So if we go back to repeater, there was the tracking ID cookie. So let's copy that, which was equal to this over here. And we want to add our SQL payload to that. So SQLi payload encoded, similar to what we were doing over here. Next, we need to add the second cookie, which is the session cookie, because the application won't function properly without it. So let's copy that. Put it over here. Okay, and then we make our requests. So it would be r is equal to request.get, and the reason we use get is because it makes a get request over here, and it would be the URL cookies equal to cookies, so the ones we just set, and then verify to be equal to false. We don't want to verify certificates, and proxies to be equal to proxies, so that all the requests that it makes get sent to my burp proxy in case I run into errors and I need to debug it. And then I'm going to say, so let's put that up, if r.statuscode is equal to 500, then I found one of the characters of the password, so I'm just going to add it, append it to the password extracted variable, and we use the chr method so that it converts it from ASCII back to a character, and then we're going to output it to the screen. So dot write carriage return plus password extracted, and then we'll flush it, and then we'll break. So if we found a character, we're going to get out of this for loop and move on to the second position in the password. So the second character and then the third character and so on. This makes it a little bit more efficient. There is obviously much more different ways to make it efficient. For example, using the binary method, which we're not going to cover today. So otherwise, you didn't find the correct character and we need to continue. However, I wanted to display it on the screen, all the characters that it's trying. And that's why I'm using the std out over here. So carriage return to return to the new line, and then password extracted. So far what we've extracted plus the character that it's trying, and we flush it again. Okay. All right, here we go. So it should show me all the characters it's trying. If it finds a character where we get a 500 response code, then it adds it to password extracted, and then it moves on to the next character and so on until it goes through all 20 characters. So let's save that, go to terminal, new terminal, and see if it runs correctly. So that would be Python 3, SQLi, lab 12.py, and this might have timed out, so let's click home, and it did. Okay, so we don't want it to we don't need it to be intercepted by burp anymore, so I'm going to turn that off, close this, and create a new instance of the lab. And when we do create a new instance, we do have to change the session and the tracking ID cookies, so we're going to have to do that. So let's remove that, remove this one as well, and we'll update them once we have a new session. Okay, looks like it opened up. I'm going to use my cookie editor extension to do this, but you could do this with burp or the browser tools. So that's for session, and I copied that twice. Next, we'll do that for tracking ID. And see if we get any errors. So Control S to save it, and then we need the URL. Let's copy that. Paste it and hit enter. Okay, so now it tells you what it's trying, and once it finds the first character, it'll move on to the second character and so on. So it's trying numbers right now. It tries then more special characters and then capital letters, and then it'll try the lowercase letters until it finds one. Now, this is going to take a couple of minutes, so it could take from 2 to 3 minutes up till 10 minutes. It's still faster than burp. However, I'm not going to make you wait all this time, and so I'm going to fast forward the video so that it takes maybe 20 seconds instead of you having to watch the screen for 5 to 10 minutes. Okay, so it looks like it's running through all the characters again, which means that we have an error in our code. So I'm going to stop this because this is not being done right. And I'm going to go back to see where the error is. And I know what I did wrong. Over here, we're giving it the first character of the password. We're asking, is the first character of the password equal to this variable over here? Now, this variable is in ASCII. However, the first character of the password is a character, and so we need to convert this to ASCII in order for it to do a proper comparison, and then they will be equal, and at some point you should get the 500 response code. So let's save this and try it again, and this should work. And again, I'm going to fast forward it until we find the first character. Once we do, we'll fast forward it on all the other characters. Okay, and we get an error at L, which means L is the first character. However, I know the issue over here at line 20, I spelled that incorrectly. So if you go line 20 over here, it's CHR instead of CHAR. Okay, let's make sure. So this is done correctly over here. That's good. All right, so we shouldn't get any more errors. Let's try again. And again, I'm going to fast forward right now until we've enumerated the first character, which should be an L based on how it ran the first time around. Okay, so we're getting closer right now. And here we go. It's actually an M because that comes right after an L, and that's why it threw an error before. But this looks good, so it enumerated the first character, and now it enumerated the second character, and it's trying the third character, and so on. So I'm going to fast forward this until we've enumerated all 20 characters, and then we'll try to log in with that account. Okay, it looks like it completed. So let's copy this and try to log in with this password to the administrator user's account. So click on my account, click on administrator, paste the password, hit login, and here we go. It says, congratulations, you solved the lab. Okay, so we've successfully completed the exercise. To recap, we first exploited a blind-based SQL injection with conditional errors using Burp Suite Professional, and then we scripted it using Python. In the next lab, we'll start looking at time-based SQL injection.